Welcome to video lecture. Good morning to all. A course material on AI 3403 Strength of Materials for Agricultural Engineering presented by R. Raju Gandhi, Assistant Professor, Department of Agriculture Engineering, Rohini College of Engineering and Technology, Palkulam. Today we discuss about thin spherical shells. A thin spherical shell of internal diameter d and thickness t and subjected to an internal fluid pressure P. The fluid inside the shell has a tendency to split the shell into two hemispheres along x-axis. The force P, which has a tendency to split the shell. That is, some of the figures is available. Resisting area is equal to P into pi by 4 into d square. The area resisting this force is equal to pi into dl, or circumferential stress, induced in the material of the shell is given by sigma 1 is equal to force P by area resisting of the force P. Therefore, P into pi by 4 into d square divided by pi into d into t. Therefore, P d by 4t. The stress sigma 1 is tensile in nature. The fluid inside the shell is also having tendencies to split the shell into two hemispheres along y axis. Then it can be shown that the tensile hope stress will also be equal to PD divided by 4T. Let the stress is sigma 2. Sigma 2 is equal to PD by 4T. The stress sigma 2 will be right angles to sigma 1. Then next one example. A vessel in the shape of the spherical shell of 1.20 meter internal diameter and 12 mm shell thickness is subjected to pressure of 1.6 Newton per mm square. Determine the stress induced in the material of the shell. Given data, internal diameter d is equal to 1.2 meter, shell thickness t is equal to 12 mm, fluid pressure P is equal to 1.6 Newton per mm square. To find stress induced in the shell, sigma 1. Solution. The stress induced in the material of spherical shell is given by sigma 1 is equal to Pd divided by 4T is equal to 1.6 into 1.2 into 10 to the power 3 divided by 4 into 12 equal to 40 Newton per mm square. Result. Stress induced in the shell sigma 1 is equal to 40 Newton per mm square. Then next example number 2. A spherical vessel 1.5 meter diameter is subjected to an internal pressure of 2 Newton per mm squared. Find the thickness of the plate required if maximum stress is not to exceed 150 Newton per mm squared and joint efficiency is 75%. Given data. Diameter of the shell D is equal to 1.5 meter. Fluid pressure P is equal to 2 Newton per mm squared. Stress in material sigma 1 is equal to 150 Newton per mm square. Joint efficiency is equal to nu is equal to 75%, therefore 0.75. To find the thickness of the plate, the stress induced is given by sigma 1 is equal to PD by 4T. Let me substitute the values. Therefore, rewrite the formula. T is equal to PD divided by 4 into sigma 1 is equal to P is equal to 2 into 1.5 into 10 to the power 3 divided by 4 into 150. Therefore, we got the value for thickness of the plate is 6.67 mm. Then problem number 3. A spherical shell of internal diameter 0.9 meter and of thickness 10 mm is subjected to an internal pressure of 1.4 Newton per mm squared. Determine the increase in diameter and increase in volume. Take E is equal to 2 into 10 to the power 5 Newton per mm squared and mu is equal to 1 divided by 3. Given data. Internal diameter D is equal to 0.9 meter. Thickness of the cell T is equal to 10 mm. Fluid pressure P is equal to 1.4 Newton per mm squared. To find increase in diameter and increase in volume dd and dv. Solution. We know that del d is equal to pd divided by 4te into 1 minus mu into d. Okay, then substitute the values for p is equal to 1.4 into d 0.9 into 10 to the power 3 divided by 4 into 10 into 2 into 10 to the power 5, then 1 minus 1 by 3 into d 0.9 into 10 to the power 3, then 0.0945 mm equal to del d. Now volumetric strain del V by V is equal to 3 Bd by 4 Te into 1 minus mu. Therefore, rewrite the formula dV is equal to 3 Pd divided by 4 Te into 1 minus mu into capital V. The capital V is equal to 5 by 6 into d cube. Then substitute the values for this formula. 3 into 1.4 into 0.9 into 10 to the power 3 divided by 4 into 10 into 2 into 10 to the power 5 into 1 minus 1 by 3. Then we substitute the value for V. 5 by 6 into 0.9 into 10 to the power 3 the whole power 3. Then we got the answer for increasing diameter DD is equal to 0.0945 mm. Increasing volume dV is equal to 12,028.5 mm cube. Thank you.